Okay, so welcome everyone. Welcome Dave, otherwise known as Dr. David Robinson. He's the New Jersey State Climatologist and has been for at least 26 years. I think you're due for a change, Dave. He's going to talk to us about climate change impacts in New Jersey waters. He oversees the Rutgers New Jersey Weather Network, which measures our weather, sits on a lot of state committees, and provides public education like this. And he has a satellite-derived database of snow cover over the Northern Hemisphere and was the first to identify the progressively early loss of spring snow cover in mid and high latitudes. He teaches courses in climate change, physical geography, and geography of New Jersey, has been on various boards, is a past president of the American Association of State Climatologists, and holds the Lifetime Achievement Award of the American Association of Geographers, among other very important positions to which I'm sure he's made great contributions. So I think we're really very honored to have Dave talk to us today. Appreciate, Dave, you taking your evening to do this. And if you'd like to correct or add to anything I've said and then start your presentation, that would be great.
Yeah, that's great, Peter. Thanks very much. It's a pleasure to be with you this evening. Yeah, you said I need a change from 26 years as a state climatologist. It's actually over 30 years now.
Must have stolen an old bio.
September 91 was the first time. I was very, very young. But little did I know 30 years later, I'd be the longest serving state climatologist in the nation. But not the oldest state climatologist. Getting close, but not the oldest. So why don't I share my screen? And how does that look?
That looks good.
That looks good. And we'll start talking about New Jersey's weather, New Jersey's climate, New Jersey's changing climate. And again, it's a pleasure to be here. You can see where I'm from. In terms of my professorial position at Rutgers, where this semester, for instance, I'm teaching a course on climate and climate change. And I'm also teaching a broader course on the geography of New Jersey, where I get to go beyond climate and physical geography and environmental geography. And this week it's demography, culture. Am I qualified? Well, you know, I'm a geographer. Am I qualified? Yeah, well, I was born in Hackensack, so it's kind of a good juxtaposition of where we're talking tonight. My parents both grew up in Hackensack. I grew up in Tenafly, so I am a Bergen County guy, but have been down here in central New Jersey since coming to Rutgers. After being up in Mike Passo's haunting grounds, sometimes at the Lamont Doherty Earth Observatory, at Columbia University, where I did my graduate work, and 4 years as an associate research scientist. So I'm born, raised, and bred on New Jersey's weather and climate, and just a pleasure to be serving as your state climatologist for many years now. I understand some of you are out of state. I heard someone's in South Carolina. I was on a meeting today with the state climatologist of South Carolina, who's a dear friend, and the state climatologist of New Hampshire, Vermont, as the three of us hashed out a few things with the national organization. And Hope Mazel told me that South Carolina was 86 degrees over the weekend. She said 86, and we said 86 miles an hour for your wind gust, and she goes, no, 86 degrees. I guess we remember what that's like. I grabbed the satellite image just for fun today, a MODIS and NASA MODIS satellite image of taken mid-morning today. And this is New Jersey, if you can tell. This is the snow-free part of the state. This is the snow-covered part of the state. You can see it runs down through Allentown and not quite to Harrisburg, and then some obviously up to the north. But the snow line is north of 195, wherever you might be. I'm right about here, and I can tell you I was skiing on 4, 5, 6 inches of ice earlier this afternoon. That was next to impossible. On the golf course, I cut tracks yesterday when it was 45 degrees. It was impossible to ski really today. It was so icy, but there's a very sharp line between having multiple inches of snow on the ground and wondering what snow looks like. And that's the wonder, the beauty, the variety of the weather and climate we have in this great garden state of ours. Here's a little bit, don't worry, we won't be here all evening, be zipping through a bunch of slides here. I'd be happy to leave some time for questions at the end, and I'll stay on until the last questions asked and answered. Greetings from the State Climate Office. We are an entity at Rutgers University. My appointments through the Dean of the Experiment Station and School of Environmental and Biological Sciences at Rutgers. I've been through about 4 or 5 deans and similar number of interim deans in my tenure. The appointment is made at Rutgers via decree going back to Governor Byrne in the 1970s, when state climatology offices were abandoned by the federal government and taken over primarily by land-grant universities around the nation. And we're a service. As your state university, we teach, we do research, and we have a service component. So we're here to help people address questions that are related to weather and climate. And if you think about it, just about everything has some relationship to the weather and climate, the environment, our health, our safety, our transportation, our agriculture, and on and on and on. So we don't make the decisions for these people, but we provide the information to help them make informed decisions. And again, that's from the homeowner up to the governor when it comes to needing to make decisions. And our credo, as we work with regional and national climate entities, is that at the grassroots level, locals trust locals. We know the climate of our state. We know the data that are out there. We know the vagaries of it, the minutia of it, and that is hopefully adding value as people make decisions. This is our website, njclimate.org. I'll tell you a little bit in just a second about our weather network as well. If you love snow and you want to go down memory lane for the last month in New Jersey, if you go on our website to this winter 2021 snow event, every event that's dropped 2 inches or more of snow somewhere in New Jersey this season is documented there with a map and a county by county breakdown of stations reporting. Jeff, you're in Ocean County, a reporter from our volunteer program. We have literally several hundred people contributing observations. We map them, we quality control them, and we post them on our website as representative of conditions in that particular community for that particular event. And believe it or not, that site's hit 40,000 times just as one button right here in a snowy winter. I haven't looked at the February stats, but it's also often used to resolve snow plowing contracts, and they plow by multiple inch increments and their charges change accordingly. And we're considered an impartial arbiter for probably millions of dollars worth of snow contracts. I know I had someone call me last week complaining that our numbers cost him several tens of $1,000s in plowing because they weren't as large as he wanted them to be. What can I say? What can I say? The plowees were happy probably with the numbers, but all I can tell you is they're representative, they are unbiased, and that's where we provide value. I mentioned our weather network. We have 65 stations across the state from High Point Monument to West Cape May near the lighthouse. Every 5 minutes, they gather data on wind, temperature, precipitation, solar radiation, humidity, so on and so forth. and they're available online. Every station has its own particular web page, and here's the consolidated one. We're in the midst of updating our maps, so they're a little bit of a mess right now because we're moving them from one server to another server on campus, and then from there we're moving them up in the cloud. And the only way we could really do it was kind of do it live. And so if you go on, and our maps look a little quirky right now, suffice it to say, we're pulling in all the data in tables and graphs, and the maps are there. They're just not what you might have seen a month ago. But that software was no longer being supported, so we developed our own mapping package. Loads of fun. Anyway, so please visit the Rutgers New Jersey Weather Network, and you'll find stations all around the state. Closest to the Hackensack River, down Lyndhurst at the Meadowlands Environmental Research Institute. We partner with them with a station that they help us maintain. We're up in Hallworth, upriver, right adjacent to the Oradell Reservoir at Suez Waters treatment plant. So that just gives you a couple idea of where we have some stations up in the northeast part of the state. Anyway, this is what one of the stations look like. Very simple. There's nothing exciting about the stations. What's exciting is the information that's gathered from the stations. And there are the variables. We're all solar powered, cellular communications. We're very proud of what we've done on a shoestring budget, and hopefully we'll continue on well into the future. The network, give or take, is 20 years old. Some older stations we inherited. We continue to grow. We'll be putting a station up at Montclair State University soon, and one down at Tuckerton to just add to the mix. We also have a volunteer program that Jeff knows about, maybe a couple of others of you here. This is a wonderful citizen science program called COCORAS, and you can read what COCORAS stands for. It's national. Actually, this is recruiting month for COCORAS. They call it March Madness. Wonder where they got that from. It is a volunteer program just for measuring precipitation, rain, and snow. People go out and take a measurement in the morning. They go online or on their cell phone and enter the data. It goes into a national database, into the National Climate Archives, and it also comes back, and you can view what you've recorded, what your neighbors have recorded, what someone out in California, up in Canada, and even a few stations in the Bahamas. And it's just a wonderful, wonderful citizen science program. We have about 300 active observers in New Jersey. A little over 100 of them miss fewer than 7 days a year. You don't have to be there every day, but if you are, great. So I would encourage you, go to cocoras.org if you're interested in becoming a COCORAS volunteer. I call it a cheap hobby and a lot of fun. Great people. Oh, and this shows you some of the maps we make just from our volunteers, not from our automated stations. You can see the surrounding stations contribute as well. The left one shows you the patchy nature of rainfall sometimes, particularly during the summer, where it really matters where you are. And it's so important for agricultural purposes, flood forecasting purposes, looking at drought, and when the numbers come up zero. Now on the right, you can see just a few weeks later, there was a major rain event with a huge swath of 1.5, 2 inch plus rains up through the state. But still, notice the differences between Cape May and Cumberland County down in the south, for instance. So that's COCORAS. Now getting on, that's my advertisement, I guess you could say, for the night. Let's talk about the climate system in just a couple of slides. It's incredibly complex, and it's composed of a number of different spheres, if you will. They're all connected. That's a system. No beginning, no end. It's a system. You can't speak of one of these segments of the system without quickly interfacing with the other spheres. My favorite, the cryosphere, which I've been studying since my days up at Lamont. I can tell you, we just ran numbers today. We're the only ones in the world who ran them. It was the fourth most extensive February snow cover in 56 years of satellite records over North America, which primarily is driven by the United States during February because most of Canada is snow covered. But it was like the 43rd most extensive in Eurasia. So put them all together, I think it was the 22nd most extensive snow cover. So if you look at that, not very impressive, but the US, pretty darn impressive. The fourth most snow cover, not snowfall, but the area covered by snow. That's one way of looking at the cryosphere. But we have the hydrosphere with our oceans, the lithosphere, and of course the atmosphere. And then the energy source for it all, the sun. So it's very complex. It's a fascinating system. We know we learn more and more and more about it every day as we observe, as we try to do modeling to recreate the system numerically on the world's fastest computers. And as we just evaluate the theories behind our climate system. And we'll touch on that a little bit in a few minutes. Turning to New Jersey. We're in the westerlies, in the middle latitudes, so we get generally the same atmospheric flows across the state, but with some very interesting differences. And you folks, I understand, canoe and kayak all over the state and beyond. So you've noticed these, whether you're down in the Pinelands, on the Mullica, or up in Bergen on the Hackensack, or on who knows what it might be, Polandskill up in Warren County and Sussex County, or the Wallkill. There are differences across the state based on, and look at the variety we get in these areas too. But even regionally, you've got elevation up to the north, hills and valleys. You've got the maritime climates along the coast, with the modifying influence of the ocean waters, making the winters not so cold and the summers not so hot. You've got the warmth of the southwest part of the state where we grow many of our truck crops, low elevation, low latitude, a couple degrees lower than the north and away from the ocean. The Pinelands with their unique sandy soils, hot during the day, they cool off at night. And then down through the Piedmont, the yellowish area there, we've got local urban heat island effects, but sometimes it behaves like the highlands, sometimes it behaves like the maritime region. So kind of that in-between zone. And look at the variety of weather and climate we get. The snows, the ice storms, the droughts, the flash floods down center. That's Little Ferry, a stream that swept cars off a car lot back in August of, I think it was 2019. A rare tornado, that's at Summers Point years back. The fires in the Pinelands, occasionally some large hail, rare, but occasionally. And then one of the iconic shots from Sandy in the top left at Maniloking. But the real thing about Jersey weather, we get a taste of everything, all four seasons, all sorts of weather events, but we tend not to get the worst of the worst. And you may say with Sandy, it's worse or worse. Oh, we could have much worse scenarios than that. Big snowstorm a month ago. There are worse snowstorms elsewhere than that, and so on and so forth. So I don't mean to make light for a millisecond about the dangers of some of these events in New Jersey and the deadly nature of them. But we are really quite fortunate in some respects, being near the ocean, being 40, 41 degrees latitude, not too far north, not too far south, that we don't tend not to get the worst of the worst. But again, we get a sampler of all. You can look at this on our website if you want to track where we've been. If the water's been high on the rivers or low, you might look at the precipitation anomalies for the last 12 months. If it's green, it was wetter than it should have been that month. If it was red, it was drier. You see, we started 2020 with 6 months of average or below average precip. We finished the year with 6 months above. January was below. We're looking at numbers for February that may make it one of the 10 wettest months. And by 10 wettest, I mean in the last 127 years. We have records back to 1895. And that's those long-term top 10 records are reflected in temperatures over the last 12 months, where 10 of the last 12 months had been above average. Only last April and May, if you may remember trying to get out in April and May, it was kind of chilly after a mild winter. But then mildness returned, and July, for instance, was the warmest July in 126 years at that point, making it the warmest month, period, in New Jersey, going back 126 years. February's going to probably come in a tad below average for the first below average month in temperature since last May. So that's our climate system in a flash. Now, let's look back at how climate has varied in New Jersey over millennia and beyond. But just looking back only 20,000 years ago, you are outdoors people. You're probably well aware that the glaciers visited the ice sheet, the great North American ice sheet, visited northern New Jersey multiple times over the last million years, the latest being just 20,000 years ago, when High Point was covered by 1,000 feet of ice and Manhattan a couple thousand feet. There's evidence in the dark blue areas that there was ice sometime in the last million years, but not 20,000 years ago. The light blue is where the coverage was 20,000 years ago. And that certainly shaped the profile of our lands in North Jersey and had an impact on the rivers and streams to the south of the ice front as well. And of course, sea level was much lower because of all the water tied up in the ice on land. So there's the great Hudson Canyon. You could canoe or kayak out that Hudson Canyon to the shelf margin on your way to the beach, perhaps. So that's 20,000 years ago. The point being, the climate has changed on all sorts of time scales in the past, and dramatically so. But we're talking about changes that took place over thousands and tens of thousands of years, not the type of change we're going to be talking about shortly, which is occurring over decades or a century. So keep that in mind. Evidence, if you've hiked up around Boonton, just to the north of Boonton, you'll go to Pyramid Mountain Park and you see this wonderfully unique glacial erratic. The ice sheet essentially melted out there and dropped this huge boulder it was carrying. Boulder, it's bigger than a boulder, and dropped it on top of 3 other foreign erratics. That's not the bedrock right there. And that's been sitting perched like that for 15,000 or more years up in North Jersey, a really fascinating remnant. And throughout North Jersey, you see these glacial erratics. Sometimes the difference in the rock is very different from the underlying bedrock. Not so much here, but what's unique here, obviously, is the way that rock has been perched for so very, very long. But let's jump ahead. Whew, we're jumping into the last century plus here. I mentioned we have statewide records with enough weather stations back to 1895, and we've come up with annual temperatures for New Jersey based on several dozen stations, not just one. Going back now, we're in the 127th year of record, but here 126 years of record, and you can see a linear regression here, and essentially New Jersey's warming about 3 degrees Fahrenheit per century. That's an awfully fast pace. And if I was to put a regression line from the late 70s upward, it would be closer to 4 degrees Fahrenheit per century type of warming rate. There's a lot of interannual variability, but look at the coolest years of this last couple of decades. They're as warm as the warmest years were back through most of the 20th century. And we've seen nothing of the cold years. I talk to my students, college students. You haven't lived through an average year of temperature globally for sure, but even locally in New Jersey, we haven't seen anything like that in quite a few years. 2020 came in as the second warmest year. 2012 still beats it out globally. 2016 and 2020 are in a dead heat for the warmest year on record. But New Jersey has its regional variations. Frankly, April and May kept New Jersey out of being the warmest year, but they occurred. It happened. And we only have second ranking status from last year. So that's temperature. But a heads up, this is globally, the warming in the atmosphere is shown in this orangey red here. All of this added warmth is in the oceans. The oceans have absorbed about 90% of the greenhouse heating. Otherwise, our atmosphere would have warmed considerably more over the last century or since the start of the industrial era. So this is something we're becoming increasingly aware that the oceans are serving as a buffer of sorts for all of our greenhouse warming and the imbalance we have in our energy budget in the Earth atmosphere system, going back to this systems approach. What about precipitation? This is a century worth of annual precipitation in New Jersey. Some may remember, as do I, the mega drought in the mid-1960s in New Jersey, perhaps the driest 3 to 4 year period in several centuries, according to tree rings. But you may also more likely remember 2018 and 2011, the two wettest years in over a century of record. This was Irene, helped out in 2011. 2018 had no big tropical system. It just wanted to rain and rain and rain. So a very wet year, but notice the interannual variability. And notice how that seems to be increasing from what we saw in the first 60 years of the 20th century. So we still have to deal with very dry years, but increasingly we've had to deal with excessively wet years, which makes trying to adjust to it all the more difficult when you have to plan for increasing extremes in both directions. So there we are the ups and downs of New Jersey precipitation in recent years. We're a coastal state. It's in our blood, it's in our culture. And what about those coastal regions? And what about the inner, the inlets, the bays, the meadowlands? Well, sea level is rising. It's risen a little over a foot, 15, 17, 18 inches in the last century. It's continuing to rise. We'll talk a little bit about projections for the future in a little while, but these are gauges. I don't have the battery in here, which is closer to the Meadowlands, but I'd have to, go across the river into New York. But these are Sandy Hook and Atlantic City. Atlantic City is the longest record. And you can see a lot of, year to year, month to month variability here, but generally this upward trending sea level rise caused by multiple reasons. One goes back to the Ice Age. The land in the north with the ice pushed down the land to the North Jersey, and it actually, like a tube of toothpaste, bulged up in the south. And ever since that ice sheet disappeared, the land has been settling in South Jersey. Also, we've been pumping water out of the aquifers in South Jersey. So it's going down. And when the land goes down, sea level looks to be coming up. That's about a third of the signal, maybe a little more. The rest of it is due to the warming waters we showed just a couple of slides ago, which thermally expand, and a little bit of melting from alpine glaciers and the Greenland ice sheet. Now, this isostatic change in this bulging from the past ice age will continue at a very slow pace well into the future, but it's beginning to be overwhelmed by the sea level itself that is actually rising, more water in the bathtub, if you will. So something to keep an eye at. And again, I'll show you some projections in just a few minutes. Oops, I just zipped past. One thing we talk about with climate change is extremes, as we'll see in a minute too. More extremes in the system. I talked about the dry and the wet. And the question is, are we seeing this already? By their very nature, an extreme is rare. So sometimes as climatologists, you have to be quite patient until you get something that might appear to have statistical significance. But these are four pictures of four floods alongside the Millstone River, which is a major tributary to the Raritan down in central Jersey. Some of you canoeing the Millstone, you probably canoed the Delaware Raritan Canal, which is much better, much safer, more fun than dealing with weirs in the Millstone River. But these are southern Manville, New Jersey, same spot. We've got Floyd, we've got Irene, and we have two nor'easters. And I missed taking a photograph of this nor'easter, but suffice it to say, 5 of the 7 largest floods on the Millstone River in the last century have occurred in the last 20 or so years. Is that a sign that climate is changing and being prone to more extremes? It's suggestive of what we expect with climate change, but it's still not proof positive. But it's something we need to continue to look at within all the river basins. The Delaware had major floods in 04, 05, 06. Nothing real major since that point. The Passaic certainly shared with Irene flooding, not as much with Floyd as in the Raritan Basin. And then the Hackensack Basin, Saddle River, we know they can quite readily flood up in the northeast part of the state. Okay, so we've talked about climate past up to present.
So Dave, I think Alex has a question. Do you want to wait till the end to take questions, or you want to?
You know what? This might be a good break to take some questions.
Okay, Alex, you'll have to unmute yourself.
There you go.
Okay, so it was from a couple slides ago, so I apologize. But the one slide that you had where the heat, it was like the red and then the blue, where you said that the oceans were absorbing a lot of the heat. That one slide. Yeah, right there. I just wondered if you guys knew why it started so dramatically in, I don't know, what was that, like 1974 maybe?
In the 70s. I mean, the balance really got tripped then. And even in records we look at globally and model runs through the 20th century, there's a lot of noise, natural noise in the climate system. By that, we mean variations from year to year, season to season, and so on. It wasn't until the late 70s that a climate change, anthropogenic climate change signal, I'm jumping ahead just a minute, for a minute, emerged from the very noisy natural system. Up until the late 70s, you couldn't say with any certainty whether humans were having a direct impact on the climate system. But it was right around this time as the oceans started showing this pronounced absorption, when the atmosphere could only be, the warming of the atmosphere could only be explained by adding an anthropogenic bump to it. So that was really kind of the inflection point where things that were just kind of run of the mill had built up to the point where the oceans, as you see here, started becoming a major player in absorbing the atmospheric warmth. So a tipping point of sorts is the best really to explain it back there in the 70s and early 80s. And that's why back at that time, there were a lot of people saying, we got to wait and see. Theoretically, this should happen, but it had been cooling for a couple of decades that we think is associated with more dust in the atmosphere until the Clean Air Act helped clean things up a little bit. And by cleaning them up, they actually helped us see the warming signal better. And there was more skepticism. I was, graduate school finishing up at that point and wondering. Of course, my professor at Columbia and the Goddard Institute of Space Study, Jim Hansen, who some may know, he was a professor. Jim's known Jim for 40 years now. He was going to Congress in '88 when the Yellowstone was burning, and saying, this is human warming. And it made the front page of the Times, and everyone was like, Jim, are you jumping the gun? Is this really true? And, you know, he looks pretty darn good.
Right.
Pretty darn good 30 years later. And Jim's retired now, but still very active. I get emails from him frequently with his group that's still at Columbia now studying this. So some people saw it earlier than others in models, in theory, in ocean observations. I saw it, was the first to report on snow cover declines in the spring season, the early snow melt. That paper was published in 1990. We were beginning to gather enough data by that point. Satellite era was a decade or two old. We were getting a global picture of that. And simply the industrial era was old enough that it was starting to exert a noticeable muscle, if you will, on our climate system. A great question. Any other?
Okay, thank you.
You bet. All right, let's just move on here, and please keep those questions coming, or write them down, or put them in the chat. But let's cut to the climate change side of things. I've already jumped the gun on that a little bit. You know, climate change is happening. It's real. It's affecting New Jersey. There's really no denying the changes that are occurring. And I could talk about Arctic sea ice. I could talk about my snow cover work. We could talk about global warming. We could talk about coral bleaching. Tonight, we focused on what we've seen in New Jersey. Although, one caveat, one thing that hasn't changed, which might surprise you, and we're working on this now and looking at it, snowfall. We have not had a change in snowfall in the last century. We've had snowy decades, we've had less snowy decades. If you're like me and grew up in the 60s in New Jersey, you grew up during the snowiest decade of the 20th century. It's really, and we're looking at it now and trying to understand why that Jersey winters are warming by 3 and 4 degrees, yet the snowfall isn't declining at this point. And we think it's related to the availability of moisture, and cold air is still there. And we haven't hit that magical freezing point in those situations. So it's still cold enough to get it to snow. As you get close to the freezing point, the atmosphere can hold more moisture. So we're trying to see if the snows are occurring at warmer temperatures and are a little bit more prolific, yet still below freezing, that compared to what the snows of 50 or 100 years ago were. Maybe they were falling at 20 or 25 degrees instead of 25 or 30 degrees. These are the type of questions that they don't keep me awake at night, but they certainly are interesting and keep me interested, engaged, and away from retirement at this point. Anyway, so climate change is happening, and let's cut. That's the what. How about the why? And I've already told you what the consensus, the overwhelming consensus is within the climate community. And that is that humans are responsible for a significant portion of recent changes. Recent, I think I've already kind of defined that. It's very clear in the last 50 years, certainly the last 40 years, no questions about it. Significant, you can look at the Intergovernmental Panel on Climate Change, who think it's 90% probability, or you can look at a particular variable and state with more certainty than perhaps another climate variable that humans are having an impact. So we've got models that suggest that the only way you can explain the climate of the last several decades is with increasing greenhouse gases. You have observations that show changes occurring, and then you have plain old theory. Our planet would be uninhabitable if we didn't have a natural greenhouse effect of carbon dioxide, some methane, a lot of water vapor. That serves as like a blanket on the bed. When you go to bed, you put a blanket on you, and that keeps your heat. In that case, let's say your body was warmed by the sun. It keeps that heat within the blanket body interface. But it doesn't keep it there all night. or you'd build up so much heat, you might self-combust. Eventually, you get that heat out the top of the blanket into your bedroom. Well, the Earth's atmosphere eventually gets that heat out of the top of the atmosphere back out to space, but the heat stays longer than it would in the absence of an atmosphere. Our planet would be about 0 degrees Fahrenheit without a natural atmospheric greenhouse effect. So what humans are doing by putting carbon dioxide in the atmosphere from the combustion of fossil fuels, methane from animal husbandry and rice cultivation, and leaks during fracking operations, it is putting another blanket on the bed. And theory tells you if you put more greenhouse gases in the atmosphere, you got to have some warming. Now, a lot of that warmth is going into the ocean, serving as that buffer, but the atmosphere is going to get warmer. So you got to throw theory out the window to say that we can add these greenhouse gases to the atmosphere, but oh no, we're not going to warm the atmosphere or change weather patterns or such. So it's not just one piece of evidence. It's theory, it's other pieces of evidence, it's model output, it's this combination of information that is supporting the fact that humans are responsible for recent climate changes. These are the human factors. You can see the carbon dioxide curve on the upper right there. It just goes up and up and up. It's at the highest levels now in perhaps the last couple million years. You've got deforestation, which changes the characteristics of your land surfaces and the temperature of your land surfaces and their ability to hold moisture or release moisture to the atmosphere. You've got these aerosols, fine particles, solid and liquid particles, that some of which, as I alluded to earlier, tend to actually reflect away solar radiation and cool the planet to kind of counterbalance a little bit of the greenhouse warming. But some other aerosols, black carbon, are absorbers and they warm the atmosphere. The dust is a net cooler that balances, doesn't perfectly balance, obviously, but it puts a little hit on the warming from the greenhouse gases. The only trick here is it's easier to clean the atmosphere of the aerosols than to get rid of the greenhouse gases in the atmosphere, which have very long residence lives in the atmosphere. So those are some of the human factors. The models, just quickly, very sophisticated numerical models, the same ones that forecast the weather, the same basic physics. They're just run at longer time frames and sometimes broader spatial domains. And if you think weather forecasts aren't good, so how could these models be good? Weather forecasts are darn good. We're just gotten spoiled because a 3 to 5 day weather forecast today is as good as a 1 to 3 day forecast was in the latter part of the 20th century. And when I was a kid, you couldn't do that well in 1 day, what you can do now with 3 to 5 days. So they are really good. Are they perfect? No. But they are pretty darn good. And with that, our climate models are good as well. All right, moving on. We really are much more than halfway through. What about our climate future? Let's cut to the chase. Temperatures are going to keep rising. That train has left the station. We're putting greenhouse gases in the atmosphere. We're continuing to do so. There's all that heat stored in the ocean. Temperatures are going to keep rising. 5 degrees by the end of this century, 10 degrees Fahrenheit by the end of this century, perhaps. We don't know exactly. You may say, well, that's an awfully wide range. Why not 4 degrees too? Well, maybe. You know, the range is that wide, not because the models are that indecisive. The range is that wide because of you and because of me. And we don't know how we're going to handle our emissions of greenhouse gases in the decades ahead. If we let things continue to run amok, way up go the temperatures. If we go green and control things, the temperatures won't rise as rapidly or rise as much. So that's why you run these models with different emission scenarios. and they give you your range of where things may go. Now, most models suggest we've sealed our fate through about 2050, no matter what we do right now. But it makes a big difference what we do right now in terms of what the climate's going to be like for our grandkids and such in the second half of the 21st century. Okay, so that's temperatures and the idea of emission scenarios. Precipitation in the mid-Atlantic expected to increase or at least remain steady, but more increase in the winter and less so, maybe even a decrease in the summer. So you have to look at the seasonality of it. So hotter, drier summers, milder, wetter winters. So we're gonna have to make sure we save enough water during the winter so it's available for us in the summer. And that's a tricky proposition, as you water folks know. We haven't built a new reservoir in New Jersey since Monksville in the early 80s, when we had a drought that, no pun intended, precipitated the building of that drought, that reservoir. With all the energy in the ocean, the heat in the ocean, and the added heat in the atmosphere, and more moisture in a warmer atmosphere, we're primed for more extremes in heat, more extremes in flood, more extremes in drought. You go, hold on, Robinson. You mean more floods, more drought? Why don't you just throw the kitchen sink in there too? But the fact is, we're talking extremes and variability. And think about it. If you got a warmer, moister atmosphere and you have a trigger, you can dump a lot of rain out of that atmosphere, and perhaps the extremes we're already seeing. But if you don't have that trigger, the sun keeps shining and it will start to dry things out, which will lead to fewer clouds, so the sun shines even more. And pretty soon you got yourself into a quick drought-like situation. So that's the extremes we're talking about. And it will stay dry until that next trigger comes along. And we can get that moisture out of the atmosphere, and off we go to perhaps more excessive precipitation. So streakier, more variability in multiple directions. And then down along the coast, sea levels projected to continue to rise. Let me cut to just a few slides remaining here. I think it's important to show this. This is the one I say you should show to your cranky uncle at Thanksgiving dinner, who doesn't buy much of this. This is the distribution of temperatures. Forget that it's summer, winter. It's the distribution of temperatures at many stations in the Northern Hemisphere from in the 50s to 80. Most of your days, if you will, were in this normal range, but you had some colder days and you had some warmer days, and occasionally an extremely hot or an extremely cold day, but they were rare. So go ahead and let's look at 10 years in the early 21st century, same stations, let's plot them up. And there's your plot compared to the older plot, faintly a shadow of it underneath. And you can see all of a sudden those somewhat rare hot days are quite prevalent. And those almost non-existent extremely hot days have become, expected from time. But, and here's where the cranky uncle comes in, who says, look what we just had in Texas. Look at what we just had with the snow in New Jersey. Bunk about this climate change. Well, the point could be made that there's still a probability of being cold. You can still have cold days, cold weeks, cold months. It's just they're less common than they were just 50, 60 years ago. And that's what this figure shows. We can still expect climate variability with some cold and some warmth, and also some extreme warmth. Why last year in New Jersey, 6 of the 12 months ranked in the top 10 for warmth in the last 126 years. So clearly this graphic holds for New Jersey. It's just easier to be warmer. Jim Hansen used to talk about, he'd bring a fuzzy dice. You say you've just loaded the dice. You've put extremely hot on 2 sides now instead of 1 side in the past, for instance. So it's more likely to come up hot than cold these days. So I think that's why I like to show this figure, to give people a perspective that this isn't going to be every day, every month, every year warmer than the last one. There's still a lot of variability within our weather and our climate. Now let's jump to sea level. This is a study that I was a part of with a whole bunch of other people. Back late 2019, we released this. It was an update of a 2014 study. And I don't like to show tables normally, but I wanted to show you the thinking that goes behind this and the probabilities we talk about. We don't talk in deterministic numbers. We talk about, for instance, the year 2100, with a moderate emissions scenario, there's a 50% chance that sea level will be about 3 feet higher. If we go green, and there's a 5% chance sea level will only be another foot higher. But if we have high emissions, there's a 5% chance sea level could be almost 9 feet higher. So that's a huge range, in part due to these emission scenarios, and in part due to the probabilities that are ascribed within each of those emission scenarios. So it's a lot of numbers there, but I want you to appreciate that this is not a deterministic study where it's going to be X, it's going to be Y. We can't tell you that. We can give you ranges based on human behavior over the coming decades. And with that, on the left is the areas that the storm surge affected the Meadowlands and New York Harbor and such from Sandy. And it's interesting, it looks very similar to the extent that we expect there to be chronic inundation with if sea level were to rise 6 feet by 2100, it would permanently be like the flooding that occurred, obviously episodically, with Sandy. So every day would be a Sandy in terms of flooding if sea level were to rise 6 feet by the end of the century. Now, it's not the highest probability. Remember, the highest probability with modest emission scenarios is about 3 feet. But think about it, even if it goes 3 feet, you get just a modest nor'easter. It could bring sea levels up as high as Sandy. And God forbid we get another Sandy, it would bring sea level up another, the surge up 3 feet higher than that. So keep that in mind. This is just everyday sea level, not, and then you put a storm on top of it. Just like Sandy was a storm that was on top of a foot of sea level rise in the last century. Had it occurred a century ago, the inundation would have been a foot lower. So there we go. And if it hadn't been at high tide and hadn't been with a full moon, yada, yada, yada. All right, now just a couple slides to finish up here. Potential impacts. They're everywhere. These people are telling me how they're seeing change go. Longer seasons for infectious diseases, for insects to come in and cause problems. The agricultural community is faced with that. The foresters are seeing southern pine beetles being able to, this invasive species being able to winter over because our winters aren't as cold as they used to be. Water resources, we've got streakier patterns of wet and dry conditions, and so on and so forth. We're already seeing the effects of climate change throughout many aspects of our state's very being. Okay, so that's quick through that. Now, a preachy slide, and some, Mike, you've seen this before. Well, oh no, I have to get to this one first. This is really interesting. Why are we here talking about this tonight? What's the big deal? Don't we have enough other things to worry about? Yeah, we do, but this is just off the presses from the World Economic Forum. They update it every year. I just grabbed the 2021. This graph shows all sorts of global risks, purely human, also natural, or at least somewhat natural, maybe with human input to them. And on this side of the graph is the severity of the impact increases. So the greatest impacts up here, the likelihood increases here. So in this corner, you have high impact, low likelihood, and that is weapons of mass destruction. Now let's go to high impact and high likelihood. This is infectious diseases. It wasn't quite as high last year on the graph, but what's over here? High likelihood, high impact, climate action failure. And down here is human environmental change and natural resource crises and extreme weathers over here. Extreme weather fell. Every year it changes a little, but that's why we're here. We're talking about a crisis that has a high likelihood and high impact, among the highest of any global risks. And it's not just New Jersey, obviously. There are more impoverished areas of the world that are far more vulnerable to climate change, to sea level rise, to excessive heat, to not being able to cope with it nearly as well as our developed, further developed society. So what do we do about it? I don't want to leave you guys totally depressed tonight. First of all, thanks for tuning in, if you will. The more we understand this, the more we all agree what's happening and why it's happening, we can start to be more unified in doing something about it. But first, we have to get everyone accepting and understanding what's going on in our climate system, how it's changing and why it's changing. With that little better in hand, we can work on mitigative actions. Go greener, use less energy, use cleaner energy. That can be done at the local level, the personal level, to the local level, to the global level. I'm not a social scientist, thank goodness, because they got enough to work on for a long time ahead. But we're not going to mitigate ourselves fully out of this. As I said, the train has left the station. We're going to need to learn to adapt. We're learning to adapt, and we're learning from Sandy, for instance, this nexus of extreme weather and climate. Let's look at them together. If we can do something to adapt to both, all the better. And it makes people more attentive that, oh, you're not just trying to solve something that's going to happen 50 years from now. You're trying to adapt to something that we just saw happen 8-9 years ago and likely to see happen again in terms of an extreme weather event with a little bit of a raised foundation, if you will, from climate change. So let's learn to be more resilient and adapt. And then finally, more resilient adapt. And finally, leadership, activism. Some of you may be on your green teams in your community. You know, you're an environmental organization in a sense, wanting that clean waters, the fresh water, abundant enough water, and then some activism. And it's as simple as getting out and voting for the candidates whose platforms on the environment, if that's near and dear to you, you find most amenable, most acceptable to you. So that's my preachy slide. Enough of the preaching. Let's just sum up. I'm not going to read all this to you. I highlighted some of the keys here of our wild and woolly weather in Jersey, the change that continues, the change that's likely to accelerate, the prevalence of more extremes as we head down the road in the decades ahead. With that, the impacts are sure to expand, but there is still time. I like to say that we were smart enough to get ourselves into this mess through the industrial era, the development of the combustion engine, and so on and so forth. You'd like to think that we're going to be, there are enough smart enough people out there that can help us address, I don't like to say solve, but certainly address this very, very pressing global risk. And then, of course, being totally self-serving, we need to keep an eye on things. And as an empiricist and an observational scientist, whether I'm looking at my satellite imagery of global snow cover or looking at the data that flows into our office every 5 minutes, every month, every year, we need to keep an eye on things because that's going to keep our attention. impart on the problem. So with that, happy canoeing, happy kayaking, something I enjoy. And I'm literally not quite a stone's throw from the Delaware Canal, where we bike, hike, ski the towpath, and we canoe and kayak the canal. So all the best to all of you, and I'd be happy to entertain questions you might have, additional questions.
Oh, great. Thanks, Dave. There is a couple of questions in the chat. Well, one comment that came to me was asking if we could pass on the URL for the, I guess it was the Rutgers weather website. If you know that by heart, maybe you could just type it into the chat
I know it
space.
in my sleep. It's very, we made them very simple. We have two websites, New Jersey NJ Climate, one word, .org, and njweather.org. The weather is our 5-minute data. The climate is the snow data I talked about, and so much more. So let's see here to
That
everyone.
was right.
njclimate.org, njweather.org. And then if you're interested in the volunteer program, it's rahs.org. There you go.
Okay, great. Thank you. So then the other question that's in the chat is from Philip Malta. He's wondering if ocean warming is having an effect on the Gulf Stream.
There's been some interesting work on that and just made the press. What, about a week ago, Philip, right? The Atlantic Meridional, AMOC, Atlantic Multidecadal Ocean Circulation. And it's associated with the Gulf Stream. And there's some evidence that the Gulf Stream is slowing down its transport of heat from the Caribbean and the Gulf up to the North Atlantic. And they used a number of multiple indicators that go back thousands of years to suggest that's the case. Now, if you ever saw the movie The Day After Tomorrow, that's an extreme case where it just turned off, and all of a sudden New York City was under ice, and they go through New Jersey with an ice sheet. And I remember they collapse into a mall and stuff like that. Science fiction based on a little bit of fact is always more interesting, but of course it's not purely fact. This is based on the idea you cut off the flow of heat up to the North Atlantic. Look right now, Great Britain, London, it's the same latitude of Hudson's Bay. Hudson's Bay is a sheet of ice right now and is all winter long. And that area in the North Atlantic influences all the ocean circulation at depth in the ocean and at the surface. So it would throw the entire global ocean circulations out of kilter. And so that's the idea. Now, no one thinks it's going to shut off, but there's evidence that it may be slowing down, and that's something that we're going to have to address. This is actually based on a theory, as Mike Passa might know, from a guy named Wally Broker. The late Wally Broker passed away about 2 years ago. He proposed this cessation of the current back in the late 70s, early 80s, and he actually tested the theory on my climate change class I took with him when I was in grad school. We were the guinea pigs testing out this theory. So it's been fascinating to follow this whole last generation studying this. And as recently as this past week, new findings have come out. So that's where science gets really exciting. Someone puts out an idea and then people have at it. Same thing with this uber cold that dropped into the center part of the country last week. It's associated with a theory that climate change is impacting the shape and the strength of the global polar jet stream in the Northern Hemisphere. It was an idea put out by a Rutgers colleague. She's no longer at Rutgers, about 10 years ago. And it's generated a whole wealth of research. That's when science is really exciting.
Yeah, and that I know personally parts of the Gulf Stream because I grew up in England, and the weather there is, although it's much further north, is much more, even more moderate than New Jersey. But if the Gulf Stream failed to deliver that effect, it would be pretty devastating on that island.
Well, there is some evidence that that occurred as we came out of the last glacial maximum. There's something called the Younger Dryas event, about 11,000, 12,000 years ago. And they think a lot of fresh water burst out of where Hudson's Bay is from melting of the ice sheets. And that cold water covered the North Atlantic, and it stopped the process of forming what was called deep water up there. And it sent at least the North Atlantic region into a much colder period for about 1,000 years before the warming coming out of the last glacial maximum continued. So we've already seen evidence on that on, again, centuries, 1,000-year timescales.
But now it's happening faster.
Well, maybe, yeah, now it seems to be happening faster.
So Joan Vianney had a question. She noted that they're building many apartment complexes in Bergen County, which is raising the water table. And she wonders if you have any, is your area of expertise extend to that topic?
You know, that's the wonderful thing about being a state climatologist. I get to interact with people from all different dimensions. I mean, I sit on Port Authority committees, North Jersey Transportation committees. I'm working on a precipitation study for the New Jersey Department of Environmental Protection now. So I sit on the state drought task force. I'm the one academic on that task force. And it's and what I've learned from the farmers and our experiment station agricultural experts, it's great. I'm like a kid in a candy shop. They come to me for data and information, and I get to learn what they're doing and help them. So yeah, I mean, I'm not a hydrologist. I actually started as a geologist, but clearly as we're building, you know, there's regulations not to build in wetlands now, because those are the sponges that feed the groundwater that feeds our streams and rivers.
But that's happening now, right in Paramus.
Yeah, yeah.
Whole big empty field full of wetlands, and now there's going to be a big apartment complex in it.
Yeah, yeah. Well, all I can say is I would have to look at the planning board and the state regulations. There are pretty strict regulations on the use of wetlands and the need to remediate by replacing them with wetlands elsewhere, which I don't know if it's an even match.
Yeah.
And there are real restrictions now on runoff at different complexes, why you see all these water detention or retention basins. But I'm not saying that's perfect by any means. And yeah, I mean, when my parents grew up in Hackensack, Paramus was all celery farms,
Yeah.
with incredibly rich soils, because it was Glacial Lake Hackensack, which had a very peaty base to it. So we've grown houses instead of celery, and the soils were much better suited to celery than houses.
Houses, yeah.
So Jeff Harburn is asking if New Jersey's extreme population density means that climate change has a different effect than in other less densely populated states.
Yeah, great question, Jeff. You know, I have a figure I didn't show tonight, which shows some very warm summer night, with the urban area still warm, and the rural area is much cooler by 10 or 15 degrees in the Pinelands and up Northwest Jersey. And then I show a map of the population density of the state. And it's not a perfect one-to-one match, but it's pretty darn close, showing you the impact that the large human population has. That's partially explains, but doesn't fully explain why New Jersey is one of the fastest warming states in the country. Washington Post did a series of articles last year and late 2019 on the fact that the mid-Atlantic and New Jersey in particular is one of the fastest warming states. The first article in that series was bylined Lake Patcon, looking at ice fishing contests that aren't held as regularly up there. I worked with them on this article for a couple of months, and even got me on the Today Show, sitting by the lake, where, you know, I filmed for half an hour and they put me on for one sentence.
Wow.
that series of articles, and you can look in the Washington Post, it started with this one and it went globally with articles. They won the Pulitzer Prize last year for that series of articles. It's just so neat to have been peripherally involved in that. And we don't understand why New Jersey is warming along with part of the Intermountain West and the Northern Plains. They seem to be the fastest warming parts of the lower 48. Now, Alaska's warming way more than any place else, and we know why the polar regions are warming faster. But around here, I think it has something to do with the nearby ocean and ocean warmth. It's not due to urban influences, but on a local basis, Jeff, yeah, I mean, we exert, look at your car thermometer. Drive down the turnpike, then get off, and you're a mile away from the turnpike out in the countryside or whatever, and your car thermometer may drop 4 or 5 degrees. I drive through New Brunswick in the evening, and when I get outside of there, out 5 miles from there, it's 5 degrees cooler. So we are having some local impacts due to our population density.
Hey, David, what if every car on that highway was an electric car? You still have the radiant heat off the asphalt and all that, but do you think that would be a significant difference?
That's a great question. I couldn't imagine it wouldn't be a difference. Of course, you also have the sun shining during the daytime on that macadam.
Right.
I would, I have not seen any studies that have looked at that, but I think that's a really interesting question because, they should be putting out less heat. And with that, you might have, I call them heat ribbons instead of heat islands, these roadways through the state. That would be a really interesting
Well,
study.
if you have a lot of traffic, say on a Friday of a Memorial Day weekend or something, bumper to bumper traffic going down a parkway, if you're an electric car, we just bought our first one. So we got 2 in the family now, but one full electric and one hybrid. And I'm so impressed with the hybrid even because if you're in traffic like that, it just shuts off, until the traffic moves up, it doesn't do anything. So
No, the
exhaust.
They're talking about 2030, what Ford now is saying, electric cars and all.
Bravo.
Let's hope that's the case, electric or hybrids.
Is there any work being done on different road surfaces that would be less heat
There have
retentive
been
than black
some,
macadam?
actually. Out in LA, I read something about they're trying to come up with a road surface that's more reflective, that doesn't absorb the heat. The question is it durable? Is it safe? I've heard some questions that there's a sun glare problem with the roadways. But geoengineering is a term you may have heard of. People used to get scared by that, and I still find it somewhat scary. I like to say we unintentionally got ourselves into this mess. Are we going to get ourselves in a further mess by trying to proactively go after the problem? But I think people are smart enough that we may be able to do more and more with that. Green roofs, lighter color rooftops, cleaner energy that produces less heat. I mean, we're still going to be powering our air conditioners, which belch a lot of heat out. And we're still going to be heating our homes, but maybe better insulation, more affordable. So the whole idea of geoengineering is we'll put this dust up in the stratosphere, and that will reflect away some of the sun's light like a volcano does when it erupts for a couple of years. It gets a little cooler. But it also changes weather patterns, which can change areas of drought, which just might occur more frequently where we're growing our crops. So that's why I say, be careful. This is the most sophisticated multidimensional chess game. And with chess, you've got to think way ahead. You can't just say, oh, that will do that.
It's all connected.
But
as you said, it's a system. It's all connected.
It's a system.
Yeah. So just another comment. I guess back last fall, we were kayaking out on the lake in Wawayanda State Park. I don't know if you know that one. And at the far end, there are these metal pipes that come down to the water, like several 3-foot diameter metal pipes, and go off into the woods. And someone, I think maybe it was Dean who's on this call, went back and did some research, and we found out that these were built in a great hurry during that 1965 drought to transfer water to another reservoir so that Newark didn't run out of water.
Wow.
So that was a sort of, there's this industrial archaeology artifact of, one of those major climate events that you had on your graph.
Yeah, well, there are a few other instances. Back in the early 80s drought, as I was going from Lamont into Columbia on multiple occasions, the northern walking path of the GW Bridge had a pipe built across it. And that was to take part of New Jersey's allotment of Delaware River water coming through the New York system and over New Jersey. And as far as I remember, as soon as the pipe got built, it started raining. But also Lake Kapakon, if you've canoed that is an emergency reservoir. And there was a pipeline there. I think the piping still exists, but there's been piping done. They've never tapped it. But back in around 2000, our last drought emergency was 2002. I'm in Trenton every other week, sitting on this drought task force. And the Pakon was being discussed as an option. And of course, the people on the Pakon don't want to see the water level lowered because they've got an economy. There are people who live there, there's operators and whatever. But there is piping. I don't know if it's still available, but at one time it was, to take a Pakon water, put it into, I guess, the Passaic and down to water treatment plant. So yeah, there's and Wanacue Reservoir in the 80s, a pipe was built from Wanacue Reservoir down into the Oradell Reservoir. And they pump water out of the Passaic River into the Wanacue and then can feed it down at Oradell. And there's one more story, Round Valley Reservoir in Central Jersey, which is by far the biggest reservoir in the state. That was built to supply Newark with water. But the rumor is that Hugh Adonisio, the mayor of Newark, had a buddy who was going to get the contract to put the pipe over to Newark. The guy didn't get the contract, and Adonisio said, forget about it. So that's why today, if Newark wants Round Valley water, it has to go through the Raritan and be pumped in pipes from the lower Raritan up towards Newark. So it's a fascinating infrastructure of water in the state. And it's better organized and prepared than it was in 2000, in 1980, and 1965. But still, we have an extremely finite amount of fresh water in New Jersey. New York City built a much better system in the Catskills in the late 19th century.
Yeah.
And I fear for an extended drought in New Jersey and the impact it could have, because we've come close, real close, a few times.
Yeah. So the politics and the corruption around water in California get a lot of attention and fiction and movies and so on, but it sounds like New Jersey could run it a close second.
Well, it's in the running, let's put it that way.
So other questions?
Another question, Jeff,
the Kirkwood Cohansey aquifer underneath the Pine Barrens. Is there any way of getting more water out of that in the case of drought?
Yeah, that's trillions of gallons of water. You realize by the time you get down to Cape May, you go through over 6,000 feet of sediment before you get down to bedrock. That's a big aquifer. And as a matter of fact, Philadelphia tried to tap that over a century ago. And Jersey said, not so fast.
Right.
And the Pinelands Act followed subsequently, much later. So Philly tried to get their hands on that, like New York City got our hands on the Catskill water. I don't know the economics, Jeff, of getting that water out of the ground. And you darn well know South Jersey is not going to be at all pleased if they're providing that water to North Jersey. I've also had someone, whenever we've had drought hearings, because when you're getting near to declaring a drought watch, not No, a drought warning. Drought watch we can put out without going with a public hearing, but a warning before an emergency, you have to have a public hearing. And I'm always asked like 3 or 4 times over the years to testify at these. And there's some guy that's come up to me multiple times and say, we need to build a pipe from Lake Ontario down to New Jersey.
Yeah, right.
And you think about it, Lake Ontario is huge and deep. That's why it doesn't freeze. I mean, look at some other nations and the way they transfer water. Is this a viable option? I've never really tested it on any hydrologist, but you get in a crisis, all of a sudden these things become possible.
I guess there's no pipelines in the planning stages, though, going from my neck of the woods up to Bergen County.
No, not at this time. But as I said, they've interconnected the waterways to distribute water more, I won't even say equitably, but to be able to handle shortages. Because, the Hackensack, that's the worst. I mean, Suez water to Forest, to Pan, Oradell, those are tiny reservoirs
Yeah.
in many respects. And that part of the water system in New Jersey gets in trouble much faster than any other part. And I remember back in house sitting back in 1980 when the Hackensack Water Company at that time, there was actually rationing of water. You were supposed to only use 50 gallons a day a person. And I asked people around the country, the state climatologists, have you ever had to ration water? And the only ones that have applied affirmatively were in Hawaii. But I said, I had to, in 1980 or 81, I was told to ration water or I could be fined. Most people don't have any memory of that. And it wasn't all the state, but it was definitely the northeast part of the state. Anybody remember that?
I do.
Yeah.
We were here then. It was.
The Oradell Reservoir was like 25% of capacity. And it was, I think it was middle of winter or early spring when it should almost be full by then. And it was like they were going to be sucking mud. They were talking about pumping water out of ponds or letting places burn. I think some of that was for the drama to bring it to people's attention. But,
I would not be surprised if it happens again.
yeah, that was a serious situation back then. Yeah, I agree with you.
They don't allow washing of cars. I mean, that we've seen plenty of times.
Yes.
Those pipe fans, yeah.
Yep.
That stuff was back in the 60s. Dave's too young to remember the
Which Dave?
Robinson.
I remember the mid-60s drought. I remember taking wash water from my mother doing dishes and carrying it out and putting it on the rhododendron bushes in front of the house.
Yes, but what was the most important phrase for saving water at that time?
With a friend.
Right.
Well, I was a little too young to appreciate that. But that was a tough one. I mean, that was really bad. And it was a different dynamic. That's what we call the Atlantic basin was very cool. The waters were very cool off the East Coast at that time. So that was kind of a cold, dry drought, as opposed to what we had in the early part of the century, which was a much warmer period, but we just couldn't get the trigger to get the moisture out of the atmosphere. So that was a very different kind of drought, we believe, the cause of that, which you couldn't evaporate enough water off the cold ocean surfaces off the mid-Atlantic. But we haven't seen anything like that since. And we may never again in our lifetimes, given how much we've warmed up our ocean waters. I suppose if that's one good thing about warming, that we might stave off a multi-year drought in the mid-Atlantic. I don't know if that's the best price to pay for that, but something to consider. Well, you folks, have you seen, I mean, the water levels up and down, some of the rivers are controlled, but you may have noticed that they're more variable through time and season. Mike, you had a question.
Yeah, do we have any dendrochronology studies of the droughts in New Jersey?
Yeah, there have been. Well, not so much Jersey. There was some studies, Ed Cook and, all those,
Yeah.
those folks, and Roseanne Dorico, and Gordon Jacoby before that, may he rest in peace, up the Hudson Valley and in the Potomac Valley. So when I talk about the greatest drought of the last 400 or 500 years, I say mid-Atlantic, because I'm not aware of a study that's been done specifically in New Jersey. I'd have to ask some people up there. One of my former grad students, Nicole Davi, she's a professor at William Patterson. I should ask Nicole. She's worked in the, except
I'll
her
send an
dissertation.
email
Her
to-
dissertation was Mongolian drought,
No,
not,
not New Jersey.
not New
I think we
Jersey.
cut down
Well,
on
that's
that grade.
where the grants were.
Yeah, well, yeah, and the excitement of that.
Okay, I'll send a message to Nicole and see whether she can answer it.
Yeah, ask her if there's been a Jersey centric. We don't have a lot of old trees. We can piece some records together, but I don't know if someone's found the right collection of trees to do a study specifically on New Jersey.
So Bob, you're always looking at the water flows, but mostly what's coming out of reservoirs. In your experience, changes over your paddling lifetime?
Well, a lot of, in recent years, I found that the Water Authority has been pretty consistent about letting spruce horn water into the South Branch of the Raritan. And that in years back, they weren't really, once you got past Memorial Day, it was catch as catch can if it rained. But now, basically all summer long, there's a minimal flow. I think it had to do with a compact they made to try to keep it a more viable fishery. And of course, we often, not last year because they had lowered Round Valley for reconstruction of dams, but the year before, we paddled the system of the Lamington, the South Branch, Rockaway Creek, Lamington, and North Branch, when the water coming out of Round Valley. They were lowering it. And, so if you're looking at those sites and you look at real-time river flows, you can kind of tell when they're doing it, but they don't tell you prospectively when they're going to release the water.
Yeah. Oh, that's a great input. Spruce Run, I remember 20 years ago getting a call from an operator there of a concession stand or whatever, complaining to me that they were letting the water go down too much in Spruce Run Reservoir, and they were having to close the docks and such. And what could I do about it? It's like, nothing, sorry, but interesting. Round Valley, they lowered it for dam repair, but also they are not pumping as much water up into it because the Raritan silted up where their pumping station is. So that I just got drought indicators today sent to me from DEP. I get them every week. And the only one that's not green lighted throughout the state, groundwater, precip, river flow, is reservoir storage in central Jersey. And it's been like that for the last couple of years because Round Valley is being kept lower.
Yeah.
Round Valley is a perched reservoir. It has no watershed to speak of. The Raritan's pumped into there.
At the pump station this year, I paddled it quite a bit because in the pandemic, I could use my bicycle to get back to Clinton. And they started, I think, in April, and they completely dug out the area where all the silt had clogged was up. They took it down somebody told me 8 to 10 feet, but they had construction going all the way into September, October, to then be able so that they could more readily pump the water up.
That's great news. They have to do the dredging. They've been dredging the Delaware Raritan Canal the last year or two. And I remember a couple decades ago when I was new down here, they were dredging that as well. And you say, how does that get silty? It's Delaware water running down through there, but silt gets into it.
Well, it's just the leaves off the trees build up in the canal because there's no real flow to flush them out.
Absolutely true. So, and you guys are there. I mean, you see these things, and that's what's so interesting by being out on the water. You can appreciate all that's going on. It's like the health officials telling me about the climate change or weather patterns, and the farmers, of course. Love to talk to them.
Yeah.
All right.
So
Any other questions?
I warn you out yet?
No, I mean, I just like to say kudos for the CocoRoz program. I mean, if anybody wants something to do in the morning and take some data, it's a lot of fun and it's really useful too. I live in an adult community down here, and the head of the landscape committee, he'll refer to the numbers that I post, all the time. Also, I do a lot of hiking down here in the Pine Barrens now, Outdoor Club of South Jersey. And, there's no snow at all right now, but it's interesting to see, how much water or snow is on the ground that when we go out in the morning, I take a look at those figures.
Yeah, and this program, we have cooperative observers around the state that have been with the Weather Service for centuries. The New Brunswick state, not centuries, decades, New Brunswick station since 1893, but they're limited. Our CocoRoz observers are getting a better picture of the snowfall, and Jeff, as you said, the water content of the snow. I mean, I had 4 inches of liquid in that snowpack just 10 days ago. And so it was most of North Jersey. Some of North Jersey still has 3 or 4 inches in it. I'm down to a little over an inch in it. And there was a big flood threat, and it still exists up in the highlands. If that snow melts too fast and is accompanied by rain, we saw it in 96 after the big blizzard, for instance, major flooding. And none of these co-op observers measure water content of the snowpack, and it's the CocoRoz observers that are doing it. Incredibly valuable civic contribution that's going to potentially save lives. Plus, it's just interesting to see.
Yeah, to see what your neighbors, the next county over, the next town over, what kind of readings there are, how it varies. Just
Yep.
If anyone wants to take on Thursday or Friday, we could measure the snow content. Wildcat Ridge, I'm still going. Plenty.
It'll still be there.
It
looks real warm the next 2 weeks, though. So
it's going to be the next few nights, and maybe 38, 37 during the day.
Oh yeah, no, the pack will be good until early next week, and then some of the models are showing.
Tomorrow's going to be 50, maybe.
Yeah,
So
tomorrow's going to be a big melt day too.
I might see my crocuses next week.
Yeah, you just might start to see them emerging from those south sides of your home, which are already probably should be mostly snow-free most anywhere.
Not where I am.
The very first blizzard that hit us, the big one, I made a snowman that was a scuba diver snowman.
Oh, cute.
Only 1 or 2 days ago, I finally got the tank. I found the tank because it was buried with all the other snowstorms.
That's it. Well, we moved into a new community a couple weeks ago, and our welcome was there's mailboxes in this community. And they unearthed all the mailboxes on our street, except where was our mailbox? Well, I found it in about 12 pieces. We're on a cul-de-sac, and there was 8 feet of snow on top of it. Needless to say, we're going to be compensated for that. But it was like, welcome, crush.
Yeah. Your mailbox is where we plow all the snow.
And they gave me a temporary one, and everything is very nice. No, there's a bigger pile of snow across the street. It's about 8-9 feet high still. But yeah, I mean, this was tough. This was unusual. Not something we see every year, but not unprecedented.
I remember being in Minnesota, and the snowplow first goes through and clears the streets. And then he sets his plow about 4 feet high and plows the top off the bank that he's just plowed so that they don't end up with the streets like completely walled in.
Yeah, very true.
So maybe we'll get to that in New Jersey if the extremes keep getting more extreme. But anyway, so I think any last questions?
Yeah, Dave, I first heard you speak, I guess it had to be several years ago at the Pineland Short Course. That was a great program.
Oh, you know,
University.
People find me everywhere.
Yeah. Mhm.
Well, now we know about you.
Ubiquitous. And the media, oh my goodness.
Well, we really appreciate the time you spent with us and the time you spend with everyone else and with the media to keep us informed.
I enjoy talking about it. I think it's important that everyone learns more about it. And I'm just blessed to be in a position where I have the opportunity to know something about it and to be able to teach folks about it. So there we are.
Thank you very much.
Really good. Thank
You
you.
bet. Please, everyone, be well
Bye,
and
all.
enjoy the kayak and canoeing season.
Yeah.
And Mike, you get better.